Don't run with them.
Okay, ready?
Look at me.
Look over. And welcome to Ladyada.
Hi, everybody. Welcome. And thank you, of course, to our sponsors at bigscissors.com.
Yeah, we finally got to go to a bookmark that I've had for 20 years because we wanted to do a grand opening when we could do a grand opening of our factory, but we've always been kind of getting smaller spaces and bigger spaces, and it wasn't really ever set up for grand openings. But as you can see here, Ladyada has a pair of giant scissors. Here's the
Sharp as hell.
president of Brooklyn Chamber of Commerce and more. And Ladyada, you can see there, we did the grand opening on Friday in Industry City. Special thanks to everyone who showed up. But
Hold on.
bigscissors.com is where we went. You want me to go to the computer?
Yeah. For all your big scissors, we directs to this
People
location.
are like, where did you get those? And I'm like, I had a
We
bookmark.
got this grand deluxe opening kit, but you can get custom.
They are dangerous and giant and sharp, and no one is ever going to take your scissors from you and not return them ever again.
No, it's like, yeah, and definitely don't use them with paper. These are my fabric and grand opening ribbon cutting scissors only. Okay, so we had the grand opening. It was awesome. We had Brooklyn Chamber of Commerce. We had folks from Industry City. We had Ada friends from near and far who came by. It was awesome.
Yeah.
Thank you so much. Trade-off is because I was working on this grand opening. I did not get to do a lot of hardware this week because it was just we were doing some planning and organizing. But I did do a little bit, so maybe we'll do. I mean, it'll be a little compact show. We'll do a shorter version, and then hopefully next week I'll get.
It's all good. Folks understand the people that are with us have been with us for a very long time. They're part of the journey and the adventure. And I just wanted to say thank you to everyone. Between the last few years of Ladyada and I trying to get a bigger space for our team and moving to Brooklyn and having a factory that we can grow in and taking good care of everyone and doing benefits and wages and trying to start a family. And then, you know, with COVID and chip shortage, y'all fueled us. We still didn't do venture capital or private equity or loans. And it's because you purchase stuff once in a while and we appreciate it. And, you know, sometimes it takes us a little while to get to things like AdaBox. We just did an update. But we're always going to do it. We never forget. But we're just keeping on. And
never give it up.
this was a culmination. And I just want to thank everyone on the Adafruit team who made this possible.
This isn't like 1 week's work. This was 2 years.
This is 20 years, yeah.
Yeah.
They don't do key to the city and other stuff. They did this like plaque thing, which is really cool. And you know, we're just getting started. We're just getting warmed up. I feel like this is like Adafruit 3.0.
We're settling in. Well,
Yeah.
4.
Yeah, it depends on how you're keeping track of time in the matrix.
Yeah, I'm still at my MIT dorm room. I was Adafruit 1.
Yeah, so it depends if you start at 0 or 1 on your numeric system. But anyways, Ladyada, what is on your desk this week?
Okay, so this week, so yeah, big scissors. So I did, you know, I have like a bazillion prototypes with stuff I designed the last couple weeks. So they all showed up and I got the prototypes put together. I haven't had time to test them because like once you get into testing I2S stuff, like you need like 2 or 3 hours, which I have not had 2 or 3 hours in a row. But I did, I'm going back and looking at a design I did before we moved. So let's go to the overhead real fast and just out of focus. I don't think I showed this off because I think, you know, we had a couple weeks off while we were doing the like physical move of the factory. And so we weren't able to do shows. But I did do a couple designs. So this is, it's kind of like, it looks a little bit like a power boost, but it's actually like a power buck. It's a USB-C to Lipo charger and it uses the MCP. I don't think I put it on the bottom. Yeah, it just says like A for like poly charger. It has an MCP 73831, which is like my bog standard Lipo charger chip that I use for like, you know, 99.9% of my designs. All the feather boards have this chip. And then I was gonna go with a linear regulator, but to be honest, actually, it's not that much more expensive these days to put in a buck. And this has a TLV 6 something something. I'll go to the product page when I go back to the computer. It's a buck converter that I think can give you up to like an amp or so. So it's nice. It's a little bit more efficient, especially when you have like a fully charged battery, like when it's up to 4.2 volts or 3.7 volts. Like it's a tiny bit more efficient. You'll get maybe like 5-10% more out of it. So that's a little buck converter tucked in there. Power good output. And then I think I can change the jumper. It's 500 milliamps by default. That's the maximum of the MCP 73 831. But you can do 100 milliamps. Although to be honest, like 500 milliamps, people don't really use less than 500 milliamp hour batteries. But as I decided, actually this board works great. It's got like the LED indicator to tell you when the battery's charged. It's got like a terminal block output. But then I was looking at some charger chips and I found a better one. So let's look at this better one. This isn't the great search. We could cover this stuff for the great search, but let's go to the computer. So this is so I'll show you what I the way I designed it, and it's basically like 90, like I said, 90% of my feathers, 95% of my feathers. You have the USB-C come in, and it goes into an MCP 73831. The reason I like this chip is first off, it's small, it's easy to pick in place. It's kind of like no frills, and not a lot of. It's just like kind of just works. It has one tri-statable pin. When it's pulled high or low, it gives you the status. Red, when it pulls low, it means it's charging. When it pulls high, it means the charging is complete. And when it's floating, it means that the battery's disconnected or something has failed, something in the state machine timed out. And then both LEDs are on, so it's kind of like a way to tell you like something is amiss. You can set the charge rate really easily using just a resistor. Those are the resistors. It's 500 milliamps max, like I mentioned. These are, I mean, the only thing that's a little annoying about them is they don't survive having the battery plugged in backwards. And so people sometimes they want to like save money, but they like save $1 by buying batteries off of Amazon. And the batteries have the reverse polarity. And people are like, why do you have the opposite of Amazon? I'm like, why does Amazon have the opposite of me? I picked the same wiring standard that SparkFun came up with. It's been used for like 15 years
Yeah.
by every maker company is the same. So please don't try to save money.
My little pushback is like, so on one hand, like there's all this bravado and like, hey, I never want to support big giant companies like Amazon. Okay, great, don't. And then it's like, I want to support USA companies and, it's better for the environment because stuff isn't going around and like all these things. But then it's like, I'm just going to get on AliExpress and why aren't you like Amazon? It's like, okay, well,
Why is it $1? And then they blow up their $20.
So pick something and stick to it. And if you want to support the folks that are trying really hard, documentation doing, that's great. We have this polarity and our stuff is supported and everything. If you want to spin the wheel, go for it.
Well, one of the things I did because I got so like, I mean, I feel bad for people. I don't want them to blow up their stuff, but it was very frustrating because it would keep happening. And they're like, how can I not, and we put warnings, but they don't get the warnings. So now what I actually did is I have a footprint and you can see the plus and minus are part of the footprint image. So on every board, it always has the plus and minus labeled, and it actually has helped a little bit. So yeah, the USB-C into the charger. And then I have this little circuitry here before the buck converter. So, normally you would just be like, okay, well, the battery connects directly into the buck and then, you're good to go. Now you have your 3.3 volts out. But the buck converter is very simple. It just needs like one inductor. It has everything built in. But one of the things you want to do to get good, to keep your battery from constantly charging and discharging, because you don't want to do that. It's actually, you should, if the USB is plugged in, you should use the USB for the power, and then any leftover energy charges the battery. And then when the USB is disconnected, then the battery is used to charge the electronics. And that way, if you're keeping stuff tethered most of the time, it reduces wear on the battery. And you also get better power because you aren't like charging the battery and then immediately discharging it, and you know you get a little bit of jitter in the voltage. So that's what this circuit does. You have this weak, this body diode for the FET, which acts as a diode, and then this is a diode. So you know even if this was turned on all the time, this FET, you'd always have this be a diode OR of the two. But if the V bus is powered, so this is high, then this will pull up this FET and turn it off, and then you will only have the power come from the V bus through here to the buck converter. If V bus, the USB-C, is disconnected, this 100K pulls it down, which will turn on this FET hard. So you're not just using the built-in body diode, it'll actually turn on the FET and have like, you know, a direct connection between VBAT and VN. So this is a low, it's going to be much lower V forward than what your body diode is, which is like 0.2, maybe 0.3, 0.4 volts. So this is a nice little circuit, but it does require like 3 extra components. You need that extra space, which is okay, but you know, and these are standard parts, and they're not inexpensive. Like this FET is actually like, you know, it's 7-8 cents. It's not cheap. The diode is not too bad. It's a couple cents too, but it basically adds 10 cents in 3 components, and each component you can think of as a couple cents. So somebody emailed us and said, hey, check out this standalone charger chip. And in quantity, once you get to like larger quantities, it is more expensive than the MCP 73831. Yeah, -2, which is the 4.2 volt. Which is, you know, 65 cents in quantity. You can get it a little cheaper sometimes if you go direct, but pretty much it's 60 cents. And this one is like, you know, 90 cents. But it has a lot of really cool things for it. Number one, very high input voltage range. So you can use USB-C, but if you like really wanted to charge it from something else, it would be fine. You could use DC power as well. And here's something really neat. So with the MCP 73 series, I mean, don't get me wrong, I like this for it, but it can only do li-poly or li-ion batteries. So 4.2 volt high, 3.7 volt nominal, which is like 95%, 97% of all batteries out there. But once in a while, people are like, well, I want to charge an older Lipo battery, the cobalt anode version of lithium ion batteries, kind of older, like used like 15, 20 years ago. Honestly, I'm surprised the batteries would work, but let's say you have them. Those need 4.1 volts. But more commonly, I'm getting these days is people asking for lithium ferrite phosphate, LiFePO4. I don't know how to pronounce it, but life, these batteries are giving me life. The LiFePO4 batteries. So these batteries are much safer than li-poly or lithium ion. They don't, I mean, they're not like, no battery's fully safe. And you know, it's like, it's full of energy. Even like a bag of flour, by the way, can be explosive. Tell me how I know. So these batteries are safer. They're used often for like electric scooters and electric bikes and stuff because you don't want to have a bomb under your crotch. If you're going to have a bomb, you want to have the safest possible bomb. So these require 3.6-ish volt. They're slightly lower voltages, which is why people don't use them, because they're lower power density, but they're safer. So it's like, it's a trade-off. But you can't charge them with a lithium polymer battery. You need a special charger that can do the 3.6 volts. Upshot, this battery charger can do it by setting the voltage output with a resistor, which is nice. It's like, it's still hard coded. You can't, you know, you put printing on it that says, you know, LiFePO. Although, well, you can charge lithium ion batteries with LiFePO, but you can't do the opposite. It's always okay to charge a battery lower voltage, but don't charge it too high. It should have a protection circuit, but if it doesn't, it could poof on you. So that's really nice. And it's got the built-in battery path stuff for you. So this handles the V bus is here and the battery is here and it will charge the battery, but you see it has the built-in FETs with blocking diodes. So like the power can't go out, like the battery can't back charge. And then you have a regulated load. So no matter what voltage is at the bus, it will never be higher than 4.5 volts. So it has a linear regulator inside as well. It could go below 4.5 volts. Like if your battery is 3.7 volts, then it will feed into here. There's no buck or boost inside of here. It's all linear, but it will select, it's like called like power pathing or whatever. It'll connect the USB-C if the USB-C is there, or the USB or whatever solar. And if it's not there, it'll do the battery. So it's kind of got this like smart balancing. It's got the 2 status outputs, which I really like, and then it's got current sense. Only slight downside to this one, it's not the worst thing, but just to keep in mind, it only has 3 current settings, 100, 500, and 1000 milliamps. The one nice thing, it does do an amp, whereas the MCP 73 could not do an amp. It was 500 milliamps max. So it can do a full amp, which I think is good because most people have larger batteries these days. And yeah, it's a power path, and it's got battery tracking, which makes it solar compatible. It actually doesn't say it here, but it says it on the product page at TI. So you can use this chip with a solar charger, and traditionally you can't just connect a solar panel to any battery charger, because what will happen is the battery charger will be like, okay, I'm going to charge at the max rate. It'll suck the power down. The voltage at the panel will collapse, and then the charger will turn off, and then the solar panel will slowly rise up back to, because it's like, okay, now I don't have the load anymore. The voltage will rise, the charger will turn on, and it'll do the cycle where it never actually charges. It just kind of, it's turning on and off in this cycle because it's pulling too much current. It doesn't know to stop before the voltage collapses. So this one has battery tracking. So what it does is it won't charge at the max rate. It'll charge up to the max rate as long as the voltage input is a little bit above the battery. So it'll like take as much as it can before the voltage drops below the battery to keep it from collapsing. So good when you have really crummy USB cables, because if you have like a really thin wire on the USB cable, this will also happen because you're sucking an amp over like a 6-foot cable. The cable's made with like 30 gauge wire because it's like the, whatever 10-cent cable you got. And that'll also cause a voltage input collapse. So this will solve that issue. So yeah, from like weak power adapters. So, or solar. They don't say solar. I don't think the word so. It doesn't appear here, but it's interesting. It appears in the product page at TI. If you go to the TI webpage, it's like, oh, you can use this for solar. Obviously, I would test it with solar. And then this is how you check the how you set the voltage. So if you want it to be for lithium ferrite phosphate, you would use like these 2 voltages. But if you're using your standard issue lipoly, you would use like these 3 resistances to set the 3 possible options. So cool. And I like that there's the stat mode. There's like a button press. I mean, I have to read the whole data sheet, but this looks pretty promising. Because it's a very nice, I like how it's kind of got everything all in one. And it's got like temperature too, if you want to do thermistor. Okay, how are we doing? Okay, we're like 15 minutes in, yeah?
Yep.
Okay, great. Let's go. So I'm just like started creating the footprint package. So maybe my next week might have done. Let's go to the great search.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada uses her power of engineering to help you, yes, you, find the things that you need on digikey.com. Searching is an art. So if you need help with finding something, you can always tag us across all the social medias. You can email us. You can let us know in the comments, all that and more. But this week, Ladyada is looking for
non-contact infrared thermal sensors. Okay, what is this? So I used to carry this chip, this breakout, the TMP007. So a lot of times folks are like, what? Like most projects, I like to tell people like almost every project is temperature sensing. we're as humans, we love measuring temperature. Like, what's the temperature of my fridge? What's the temperature of like the greenhouse? What's the temperature inside like the center of the sun? What's the temperature of my oven, my kiln, whatever? With temperature, we love it. A lot of stuff is very temperature sensitive, so I get it. Ice makers. So we stock a couple we don't stock a ton of temperature sensors. So like, your standard MCP 9808. This is, a I2C temperature sensor, but it's a contact sensor. So it measures the ambient air or the temperature of the thing it's touching. Like, what you're measuring is the chip in the temperature inside the chip here. And we have lots of sensors that do that. We have like the BME 280, which I can't spell. BME 280, which also has humidity. We have the DS18B20s, which are, we have them in cable type where you dunk them in water. We love measuring temperatures in water. Like, is it boiling? Is it freezing? What's going on here? But all of these, you have to dunk it in. It has to touch. But there's a lot of times where you don't or can't touch the thing you're measuring. One, during COVID, very popular non-contact forehead temperature measurements. Remember that, where you go every place and they would ding, they would measure your temperature to see if you had a fever, even though like many people who got COVID never got fevers. Okay. Anyways, so we have a couple sensors that do that. One is this contactless MLX 9614, available in both 5-volt and 3-volt. This is out of stock, but maybe we have the other one. Actually, to be honest, it's just a sensor, and it's breadboard friendly, but it's I2C, so people do like this. My favorite is the thermal camera breakouts, where you can measure. This is a 24 by 32 infrared grid. There's also the grid eye, the AMG, which here we have, we've done some bicubic interpolation to make it look better. 8x8. And these are all good. But people, again, people really liked the TMP007 because it was, I never made this into 7QT because it got discontinued before I started making QT boards. But it would, you just point at the thing, and within like, a degree range, it would tell you the temperature. You didn't have to touch it. Also good for really hot things, right? Because you can't touch this to something that's hotter than like 100 degrees C without, well, possibly burning yourself. But eventually, if you get towards 125, the chip stops functioning. So it doesn't have to be close to the thing. It just has to be pointing at the thing. And so we got a request for a Stemma QT board that would be, with the TMP007 or the MLX 9614, not a camera. Also, the camera, to be honest, is quite expensive because the sensor is like $30. And then we have to assemble it and test it and stuff. But they wanted a breakout that's plug and play, ready to go for measurement with something like this. And, I'm not against just using the MLX 9614, but to be honest, this sensor is quite old. I think that we've been stocking this sensor. I mean, this is product number 1748, which means we've been stocking it for many, many, many years. We put in, on average per year, only like at the most 500 products per year. Even less. We usually do 250. So you can see it's been 10 years since we put this.
You know what I'm gonna do? I'm gonna export a data source and plot our new products at some point and do a chart. That'll be fun.
You could. It's
can.
quite easy. I have the data. I can pull
We
it.
got the datas.
I have the data.
We got the datas.
I have my scroll read access.
Ladyada's House of Data and Pancakes.
Yes. Okay, so this is the MLX 9615. So this is the sensor that I was, at first going to do, and it's about $11. There's two things about it. One, first, again, it is a little older. Second, it's through hole, not surface mount, which is kind of annoying. I'd really prefer to have something I can pick and place on. So let's look at what other sensors we can get that are digital and infrared, because it's the kind of sensor it is. It's infrared. I'm not going to select anything else because I'm going to see what's available. So you can see some of our favorites, AMG 8833, all the NLX 96 whatevers are available. Let's look at active because definitely like those TMP sensors, they got discontinued. And I'm not gonna care too much about the mounting yet. Let's do that later, but I do want to be picky about the output type. I want I squared C or SM bus. 485 and UART are both, you know, serial interfaces. And direct link is like it's I think like one wire ish. I don't want to deal with that. I want I squared C. I don't want to do a conversion. Thankfully, most of them seem to be like that. And then, this isn't too bad. I'm just scrolling through to see a lot of them. You can see a variance. So like Lexus will have like 6 billion variants, and then like AMG, they have like the 5-volt version. It's like kind of a trillion variants. There's a lot of variants. Honestly, there's not that many companies that make these sorts of sensors. You see some of the same part numbers over and over again, like the 15 trillion variants of the MLX series. But most of these are not in stock. So let's do normally stocking. And let's exclude marketplace, just so we're only looking at stuff that's stocked at DigiKey. And then I do care about price. I feel like it can't be. One of the things I really liked about the TMP 007 is it was like $3 or $4. It was not that expensive. And it worked fairly well. But like I said, you go to make breakouts with the army you've got, and the TMP 007 is completely unavailable. So I put in the quantity of 500 because, that's probably how many I'm going to sell per year. And let's see what's available. So yes, the MLX 9614 is here. But what I kind of like is, and I already have the AMG 8833, and also this is kind of getting into that too high. I wish I could filter by price and say, give me everything that's like under like $10. But what I do like is this sensor, which looks kind of promising here. It's SMT. And it looks like you measure up to 200 degrees C, which is kind of cool. I squared C, 3.3 volts, which is nice. Fairly good accuracy. There's actually there's a VCB and a DCB and an RE and an SP, which is kind of fun. We'll look at the data sheet real fast. This one is actually 0.2 degrees C accurate, which is like pretty amazing. So let's, and they're all SFN at, their surface mount. So let's look at the data sheet for this kid. Okay. FIR sensor, 3.3 volt I squared C. Ooh, you can even set the address. Great. So you have 2 of them if you so wanted to, or if there's a collision, healthcare, body temperature, industrial temperature. It looks right. Nice and small. Available both standard and medical. And then they're calibrated, but can be used. Looks like the medical version is ideal for 35 to 42. So human body and animal temperatures. But it can measure higher temperatures as well. Although the accuracy won't be as good once you get to 200, which is fine. There's usually like within this range, it's, 0.1 degrees C. And then above this range, it's like 2 or 3 degrees C. Okay, so the variants are, the first letter is B or D for medical or standard, and then they're all going to have C, they're going to have B, and then 3.3 volt, and then standard config. So we want the 000, we don't want the 1.8 volt. So let's go back. I don't think the voltages, oh no, the voltages are here. So let's make sure it can run at 3.3. No, all of them are. I'd say let's make sure it can run at 3 or 5, because that way we don't have to do a boost converter. Okay, so let's see what variants we've got here. Okay, so it's the VCB and the DCB. So one thing I noticed is that the DCB, which is that medical range one, it is a little bit more expensive. It's like $1 more expensive, but it also has a purchase limit. Although I actually might contact DigiKey to see if this is true, because I'm almost positive this probably got put in a few years ago when there was a huge rush to purchase medical temperature sensors, because everyone wanted to buy medical temperature sensors, and they probably put a limit to be like, hey, don't buy us all out, because we want to make sure everyone has a chance. And it could be that they just never react. They never remove the limit. So I'll probably contact them because it's a little bit more expensive, but I do like the extra precision. And then the other difference is this is on tray. I think this is also on tray. If you don't mind the tray, it's less expensive, but if you want a lot, the cut tape is there for you. So I'm just gonna say the cut tape because they have a lot. Kind of promising. I like to see when there's a lot in stock of an item because it means like when there's only like 200 left, I'm always like, is this something you guys are going to continue stocking? But if there's 16,000, and Ditchkey is really good about only keeping as much stock as they sell, this is probably a fairly popular sensor. So this is my pick for the Great Search for non-contact infrared sensors with I2C that are surface mountable.
That's a great search.
Where in the world is that part I need? The Great Search with DigiKey.
Alrighty, thank you so much, everybody. We are fired up, ready to go. If you thought it was hard to keep up with all things going on with the Adafruit before, oh, just you wait and see. We got a lot
I
planned.
have a gigantic pair of scissors and I'm not scared to use them.
That's right. And she is not scared of telling me, hey, go cut it up.
Go,
Okay.
go cut that guy's head off.
All right. So
Okay.
we'll see everybody throughout the week and more. Thank you so much for joining us. See you later.
Bye.